uh, when my mom texted the person, she said it was 6 o'clock. So why is it turned to 5:20?
I don't know, like the timetable that is provided to me is this time. Like it's 10:30 p.m. here, and my timetable is 10:30. I don't know what was the time given to you. That's the time given to me.
Because she said it was 6 o'clock.
No, actually, this was the time that is given to me. Like it's in my timetable. This is the time given to me. I don't know what happened. I'm not sure about this.
Okay.
Okay, so we have started just work done or work.
Pardon?
Work.
Yeah.
So how can you define the work?
So how much? I mean, the equation for work done is so for some distance. So is it just the uh how mu- how how much how much force and distance uh, something exerts?
Yes. So basically, work or work done is what force times distance.
Yeah.
So how much force is being applied to an object and how much it has displaced from its position, that is the work. If you apply force and you're not able to displace an object, that means your work is zero. You haven't done any work. So in work
Okay.
done, you have to displace an object and object has to be displaced from its position. Then it is said to be a work done. Okay.
Okay.
Now its unit is Newton meter. First, Newton is a unit of force and displacement is meters. So it's Newton meter. Okay. Now work done or work, I can say it's can be categorized as two types. One is the positive
Okay.
and one is negative.
Okay.
So positive work is when you apply the force and the displacement takes place in the direction of force. That means suppose this is an object and I have exerted a force in this direction and body also displaces in this direction, then this is said to be a positive work. Okay. And the negative work is that if you applied a force, this is a body, you applied a force in this direction but body displaces itself in opposite direction, then such kind of work is known as negative work. Okay, is this clear?
Yeah.
Okay,
Yes.
now there is a simple question. Calculate the work done when a force of 100 newtons is applied to an object and it displaces an
Wait.
object.
There's
Yes, yes.
there's something wrong with the sound. I keep hearing small beeps and when you're speaking.
Okay, so when I speak, that at that time only it happens.
Pardon?
I'm saying like when I speak, only at that time you hear the voice, like background voice.
Yeah. It keeps pausing and then saying it, and there's like small pauses
Oh,
that that I can't that I can't hear you speaking.
okay. Mm, okay, still you hear the same?
No, it's not there.
Okay. So there's a question. You have to calculate the work done when a force of 100 newtons applied on an object, and this object displaced through a distance of 2.1 meters. So calculate the work done.
Okay, so the force is 100 newtons and the displacement is 2.1 meters. So then it is 210 meters.
Yes, 210 like unit is
Newton.
it's joules. So like Newton meter, but its SI unit is joules. Okay.
Okay.
So everywhere you have to write joules.
Just asking.
Yes.
Wait. So is the force? Wait. No. Never mind.
Okay. Now the next is a work is done on a trolley of 1500 joules. It displaces an object through a distance of 30 meters. Calculate the force required.
So that is so 1500 divided by 30 is 50.
Yes.
15 newtons.
Yes, so it's 50 newtons. Okay. Now it's power. So what do you mean by power?
Not really sure.
Okay. So actually, it's the rate at which the energy is transferred is called power. That means a rate at which energy is transferred. Rate which means the time. So if you write this mathematically, so it's work done or energy over time. So it's energy over time.
Wait, so energy over time is the power.
Yes. Or work done over time.
Oh, okay. Oh, okay. Right. Wait, so is power measured in watts?
Yes.
Okay.
So there's a question. Two electric motors are used to lift a 2 Newton weight. So basically, there are two electric motors that are used to lift a 2 Newton weight through a vertical height of 10 meters.
Okay.
Motor 1 does this in 5 seconds. And motor 2 does this in 10 seconds.
Okay.
Now you have to calculate the power required for motor 1 and for motor 2 and compare them.
Okay, so the work done here is 20 joules,
Yes.
and so most people will do this in 5 seconds. So that's 4 watts of power.
Yes.
But most people does it in 10 seconds, which is 2 watts of power. So that means that motor 1 is double the power of motor
2.
Wait, no, motor 1 is double the power of motor 2.
Yes. Now a hair dryer transfers 48,000 joules of energy. In 1 minute. What is the power rating of the hairdryer?
So 400 joules in one minute. So that means, wait, does it have to be in seconds?
Yes, so you have to convert this in seconds.
Okay, so that is 60 seconds. So then 48,000 divided by 60. So it is 700.
800.
Wait, yeah, 800, sorry.
Yes, so it's 800 watts. Now there's efficiency. So basically, if I talk about any device, so they are designed to minimize the waste of energy. That's the basic work or the main
Wait,
things.
sorry, can you go back to the last page because I need to write some things down.
Okay, okay, I think I have just deleted that. Wait a second. Okay, I have
Oh,
deleted it. Okay, so you tell me what you want to write. I'll write that again.
okay.
So it was power, that was energy over time. And time should be in seconds. Okay, and you want to write down the questions, right?
Yeah, just 4 examples.
Okay, so the question was, the first one, okay, this one was that a hair dryer transfers 4800 joules of energy in 1 minute. So it was to calculate power. And another question was two motors lift 2 Newton weight vertically. Motor first does this in 5 seconds. Ten seconds. Calculate power for both.
Okay.
So next is efficiency. So if I talk about the device or any machine, they are designed specially to utilize as much as possible the energy that is being provided to that machine, or you can say to minimize the energy loss. Suppose take the example, this is a computer. Definitely a computer works on electrical energy, so whatever the electrical energy is provided to it or electrical power provided to it, say suppose it's the 100 joules of energy provided to this computer, and its work is
Mhm.
like to interpret, like to turn on the screen, so to convert this electrical energy into sound energy or light energy. So it's a useful energy. So the main aim of computer is to convert 100 joules maybe to get a 98 joules of output or 99 joules of output. If you get more and more output, that means your machine is more efficient. Okay, that means it's only 1 joule or 2 joule of heat loss. Heat loss is what, like if you touch your computer or laptop, or like if you overuse your mobile, touch your mobile, so it gets heated. So this heat is basically a waste energy. So whatever energy is input, that is get like being wasted as a heat energy. So this is not right good for a machine. So like designers, the main aim of designers is to to minimize that heat loss or to maximize the work output, and by this they make their machine more efficient. And from here, the definition of efficiency or the formula of efficiency is basically useful energy transfer divided by energy input or total energy supplied.
Okay.
That means if a machine is efficient or more efficient, so it's basically converting the total energy into more useful energy.
Okay.
So this is efficiency, and if you want to calculate the efficiency percentage, then multiply this by 100. What you have to do is just multiply this whole by 100. You'll get efficiency percentage.
Okay.
So the energy supplied to a light bulb is 200 joules. Or another way of like telling the efficiency, the formula of efficiency is output over input. So basically useful energy transferred is what? It's the output that you're getting, and total energy supplied is basically the input. So if it's in terms of power, so you can say, if suppose the powers are given in a question, so you still can calculate the efficiency by output power divided by input power into 100. That will give you the efficiency. Okay.
Okay.
So in the
So
question, yes.
no, nothing.
So the energy, so this question is, the energy supplied to a light bulb is 200 joules. A total of 28 joules of this is usefully transferred. How efficient is the bulb?
So 200 joules is the total energy supplied,
Yes.
and the And the useful energy is 28 joules.
Yes.
So that's 28 divided by 200.
Yes, which is?
Well, I'm just calculating right now.
Okay.
So it is 28 divided by 200 times 100. 14%.
Yes, that's it. So like if you have, like in the question it's asked how efficient is the light bulb, so you can say light bulb is not very efficient because it's just only 14%. That means only 14% of the total energy is converted into useful energy, and rest of the energy, that is 86% of energy, is being wasted. It gets wasted, so it's not much efficient bulb. Now there's another question. A transformer usefully transfers 190,000 watts of, so a transformer usefully transfer 190,000 watts of 200,000 watts of energy supplied to it. How efficient is the transformer?
Okay, so this is uh is it 95%?
Okay, yes. So which means the transformer is very efficient since 95% of energy supplied to it is usefully transferred and only 5% of energy is the waste energy. Now there is one important thing, that it's not possible to have efficiency greater than 1 or equal to 1. Okay,
Okay.
efficiency should always be lesser than 1.
Okay, let me,
It should always be lesser than 1. It can be greater than 1 or equals to 1. That's not possible. That means you cannot find any machine that totally converts the energy, whatever the energy being supplied to it. Or like you have supplied 10 joules of energy, but it basically converting or like giving you the output of 100 joules of energy, like greater than what you are supplying. That's also not possible. So it always be lesser than 1 or 100%.
okay.
So this is the conservation of energy. Okay. If it happens, then it will violate the conservation of energy law. It's not possible. Now there's a term which is known as wasted energy. So I've already told you that wasted energy is what? The energy dissipated in the form of heat only. Like suppose if you turn on a bulb, so what's the work of bulb? To give us the light. But after some time, like after 3 hours or 4 hours, if you touch that lamp or bulb, you feel that elevated temperature, the hotness, you can feel that. That is the wasted energy. So the energy which is not converted into a useful work, that is the wasted energy. And there are lots of various reasons. That is, the first reason is the friction between the moving parts. If the machine is moving, like bulb is not a moving machine. Take example of an electric fan. That's a moving machine. So the friction between the moving parts can cause the wasted energy. It can cause the energy to get wasted. Or resistance, if there is electrical, if there is a machine which is working on electrical energy, then it's the electrical resistance.
Okay. Wait, could you repeat that again? I'm still not.
Okay,
What are we talking about?
it's a wasted energy.
Wasted energy in forms of, okay.
Yes. So like what are the actual reason of wasted energy? Why energy gets wasted? Like why it happened that I turn on a lamp but after some time I can feel the hotness around that lamp. Why it happened? Or why like when I turn on my laptop after some time I can feel the hotness. Why it happened? Why energy gets wasted? So these are some reasons. The first reason is if suppose machine has moving parts, then the friction between the moving parts causes the heat energy to create it. Definitely friction is the cause of heatness. If you rub your hand together, both of your hands together, definitely what you are doing, it you are just rubbing and this causes the friction, and this friction actually converts into heat energy, so it's a waste energy completely. So friction between the moving parts is the one of the cause of waste energy. Second is the electrical resistance. If a machine or a device is working on electrical energy, then it's the electrical resistance. Third is
Okay.
unwanted sound energy. Sometimes an unwanted sound energy can cause waste, like energy to get wasted. There are actually various reasons, but these are some main reasons. So devices can be made more efficient by reducing the energy that they get wasted. Okay, how they can do? By reducing the friction. Suppose there is a moving part, or actually the friction is happening, so by lubrication you can reduce the friction. So by reducing the
Oh,
friction you can make the machine more efficient, and that's why like if there is a mechanical machine, generally they get oiled regularly to reduce the friction. So or like if there is a vibration or some sound energy, then you can use the dampers. Okay.
okay.
Mhm. Let me see some questions. Okay. Now, if the work done is in terms of kinetic energy, okay, like definitely energy and work done both have the same units, that is the joules. But there is some difference between the work done and energy, and that is that energy is actually the capability of doing work, and work done is actually that work. So energy makes us capable to do work, and whatever we are doing, that is our work done. Okay, so if you are doing a work, you need that energy. That's why they both have the same units. So in short, you can say the energy transferred is basically by work done. So like that energy keeps on flowing or keeps on changing from one form to another form. So like if there is a man standing at some height,
Yeah.
so at that height he has potential energy. But if
Okay.
he decided to jump, when he jumps off, he gains momentum, he gains velocity. So at that time, why? Because potential energy starts converting into kinetic energy. So what's happening? It's basically energy is being transferred. Basically energy is changing its form from kinetic energy to from potential energy to kinetic energy. But how it's converting? That's the main thing, right? Electrical energy
No,
converted into light energy into sound energy.
sorry, I can't.
Okay, can you hear me now?
Sorry, the yeah.
Okay, wait a second. I think I need to relog. I'm just logging out and then logging in. Just hold on a second. I was explaining you the conversion of energy and work done.
Okay.
So basically what happens is I was giving you the example, this one, that a man is standing on a cliff. So when he's standing, he has potential energy. But if he
He
decided
decided to
to jump off, then what happens is that potential energy starts to convert into kinetic energy. But what's that thing which is converting that potential energy into kinetic energy is the work done. Okay, so he is doing the work. What kind of work? By jumping off. So that kind of work, by doing that work, the energy is being transferred. So that's the basic difference between a work done and energy, but they both have the same unit. Okay.
Okay.
So, in terms of energy, how can we calculate the work done? Like in terms of force, we know work done is what force into distance. But in terms of energy, how can we calculate the work? Is this? First, you tell me what's the formula of calculating energy, kinetic energy.
Okay. Kinetic energy. So it is half times mass times v velocity squared.
Yes, that's correct. Now, work done in terms of kinetic energy is change in kinetic energy. Okay,
Okay.
so it's basically,
Okay.
I'm just writing it. Okay, first thing is that we have to calculate the work done, actual the total work done. So we have calculated it to be 60 multiplied by 20, which is equals to
Yeah.
1200 joules. Then there is a work done that gets, we state the frictional resistance force. So it's actually the opposed force. If it's like if you are trying to move in forward direction, the ground applies a frictional force in reverse, in opposite direction. Okay, so this has to get minus because it's opposing it. It's a resistance. So to 20, that is 1000 joules, and this is a negative work done. Okay, so this has to be subtracted. If you remember at the beginning of the lecture, I told you the work done are of two types, the positive work done and the negative work done, right? So positive is when
Yep.
when you give a force in forward direction and object moves in forward direction, and negative is when the object moves in opposite direction. So frictional force is a negative work done because it works always in opposite direction. That's why frictional work done is negative one, and this a person pushes a cart, this is a positive. So we have to take the total work done, and it's 1200 minus 1000, which is 200 joules. Is this clear? This is your net work
Yes.
done. So 200 joules is actually your net work done. Now we have to calculate the kinetic energy that the car does at the end of 20 meters. So I've told you that work done is equals to change in kinetic energy. That means final kinetic energy minus initial kinetic energy is equals to 200 joules.
Okay.
Now you know that kinetic energy is half mv squared, but here it's written how much kinetic energy does the kart have at the end of the 20 meters if it started from rest. If it started from rest, that means your kinetic energy is at v equals 0. Your initial velocity is 0, half mv squared. If you put 0 there, so your initial kinetic energy becomes 0. Is this clear?
Yeah.
So initial kinetic energy becomes 0. So your final kinetic energy is basically is equals to 200 joules. Is this clear? So like
Uh.
mass is given just like there was no use of mass here anywhere. It was an extra additional data. Okay, you tell me. Do you have any doubt anywhere in this question? Hello?
Hello. Just one thing. I'm a little confused about. Wait, could you repeat all of it? Because I'm a little confused about it.
Okay, so I'm just clearing you the whole question from the beginning. Okay. So first thing is
Okay.
actually in this question it's given as there is a person who is pushing a cart in forward direction. Okay. So this is basically okay. This is the surface. Okay. And this man and this is a cart and this man is pushing this cart in this direction. So he's basically doing the work is in this direction, but at the same time the frictional resistance, that means the resistance exerted by the board, is in this direction. Okay, so the net work done will be this work done minus this work done. Clear?
Clear.
That's why it's 1200 minus 1000 is 200 joules. So net work done is our 200 joules. Now actual you have calculated how much work done by each force acting on the cart, that's it. Second part, how much kinetic energy does the cart have at the end of the 20 meters if it started from the rest. It's very much important why the man who has framed this question mentioned this one from the rest is that there is also another formula which connects kinetic energy with the work done, that is work done equals change in kinetic energy. So I can write as work done is equals to final kinetic energy minus initial kinetic energy. But
Okay.
since he has mentioned that if it started from rest, that means initial is the point from where the journey has started. And if the initial is from the rest, that means at that point v equals 0. Rest, which means no one is moving. Then definitely velocity is 0. So kinetic energy, formula of kinetic energy is what? Half mv squared. If you put v equals 0, you get initial kinetic energy v 0. So if I put 0 in
Okay.
place of initial kinetic energy, my equation becomes 200 equals final kinetic energy minus 0. So basically my final kinetic energy is 200. I don't have to use half mv squared. I can directly calculate my final kinetic energy using this formula. Okay.
Okay.
Is it clear?
Yes.
Okay, now I'm uploading another question.
Pardon?
I'm uploading another question.
Oh, okay.
Okay, see this question. Assuming an efficiency of 25% for the muscle system in the process of converting food energy into mechanical work, how much energy would be used by a person of mass 75 kg in the process of climbing 4 flights of stairs for a total height of 15 meters? Find the answers in joules and convert to dietary calories. Okay, so main thing is, if in the question efficiency is mentioned, so the very first thing is write down the formula. So what's the formula of efficiency?
So efficiency is the useful energy output over the total energy input.
Yes, that's good. Now you have to look out where you can find the initial energy or the final energy. Okay, so read out the rest of the question. So it's mentioned that mass of person is mentioned, that's the data, so it's 75 kg. Then height climb, that is h given to you, which is 15 meters. So I'm just writing down what is given.
Okay, so so are we supposed to find the gravitational potential energy?
No, actually it's not gravitational potential energy that you have to calculate. You just have to calculate the energy required. So it's given as that assuming an efficiency of 25% for the muscle system in the process converting food energy into mechanical work. So you have to calculate how much energy is being converted into mechanical work. So food energy is your input energy, total energy supplied, and mechanical work is the useful energy converted. Clear?
Yeah, but it doesn't give us any numbers except for the person's mass.
Yes. So if person's mass is given, but also it's given the height. In the process of climbing 4 flights of stairs for total height, that person is actually climbing the 15 meters of height. That means the mechanical, we can calculate the mechanical work from here. Unclear?
Clear.
So calculate the mechanical work first.
Wait, sorry, I'm not now. I'm not sure what I'm supposed to do.
Okay. So the first thing is efficiency. Efficiency, you know, that the useful energy over the input energy or the total energy. You know. Now it's a mechanical work. That means the energy transfer that you have to calculate. Here height is given, mass the person of, like the mass of the person is given, he is climbing, that means it's the potential energy basically. So it's the mgh
Yeah,
that you have to calculate.
yeah, but what formula are we using?
Like to calculate this whole question that you are saying.
Wait, what isn't that formula just the gravitational potential energy?
Yes, mgh, that's what I'm saying. The mechanical work that you have to calculate, it's by mgh you have to calculate.
Okay.
So work done is basically gain in potential energy. How much a person is gaining potential energy is basically its work done.
So 75 times 15 times 10 equals 11,250. Then times it by by 0.25.
9.8.
Or
Like
what?
G, you have to take it 9.8 times 15 times 75.
Oh, so 1.8. So it's 15 times 75 times 9.8. It's 11,025. Now times it by 0.25, which is then is 2,756.25. And then so if this and then divide this number by 4,186.
Yes, so what's your final answer?
0.665844 calories.
Okay, so like the work done that you, the mechanical energy work that you have calculated was 11025, and then you have multiplied it by 0.25 or just divided by 0.25?
What?
You have divided this mgh, you have calculated by the efficiency or multiplied it by efficiency?
I've multiplied it by 0.25.
It should be divided. Why? Because it's, if you use a formula, so efficiency is useful energy by input energy. Okay, so this mechanical work is actually the useful energy. Okay, and input energy, the energy that you are getting from the food. Okay, and then you are converting into work. So input energy or the total energy that you have to calculate, you have to calculate this one. Is this clear?
Okay, so it is 9.8 times 75 times 15, then divided by 0.25,
Yes.
then divided by 4,186.
Yes.
That gave me 10.535.
Yes, that's the correct answer.
Okay.
Okay, now, okay. So, became the first man travel. Determine the work done by a man in deadlifting.
What? I don't see the.
Oh no, I'm just reading out the question. I'm not uploading it.
Oh,
So it's determine the work done by a man in deadlifting 300 kgs 300 kg to a height of zero point 0.9 meters above the ground. Simple. That's a very simple question. So you have to calculate the work done by a man in deadlifting 300 kgs to a height of 0.9 meters above the ground.
wait, could you repeat that, please?
Okay. So determine the work done. So you have to calculate the work done by a man in deadlifting 300 kg to a height
Okay.
of 0.9 meters above the ground. So I have just written this data. It's a 300 kg and 0.9 meters above the ground.
So that's 270 newtons.
270 newtons that you have calculated.
I mean,
Newton.
joules. Work done.
It's 2.6 into 10 to the power 3 joules. Okay, so how
Wait,
many?
how much?
Yes, yes.
How much is 200 kilograms in newtons?
Like it's not kilograms in newtons. Kilogram is kilogram. That's the mass. You have to. Okay. First thing is, let me clear you up. See, you know, work done is actually force into distance, right?
Yeah.
And force is equals to mass into acceleration. Is this clear?
Force. Yeah.
So
Oh.
ultimately, so if you are moving a something in horizontal direction on a surface, then for work done, It's mass into acceleration into distance. Okay. So force into distance, or if you split force into mass into acceleration, so it's mass into acceleration into displacement when it's
Okay.
moving in horizontal direction. When the same thing is happening in vertical direction, that is against gravity or towards the gravity, then this A changes to G and your D changes to
Okay.
H. Okay, basically your distance becomes your height. So that's why this MAD becomes MGH. Is this clear?
So,
Because G is basically, this small g is acceleration.
oh,
It's
yeah, I
acceleration due
understand.
to gravity. Okay. So when an object is moving under the gravity, then acceleration is basically and only because of gravity, and that's why we did G, acceleration due to gravity, not because of any man, it's because of gravity. That's why the object gains acceleration. So when it's moving in up and down direction, the acceleration is totally because of gravity. So at that time we don't take A any
Okay.
different way, it's just G that we take. Okay.
So, so now the work done is just the gravitational potential energy.
Yes.
So then that is 10. So that is 300
Yes.
times 9.8 times the height, which is 0.9.
Yes.
So that's 2,646.
Yes. Joules. That's energy. That's a
Yeah.
work. Okay.
It's nearly time to finish the tuition, so
Yes, actually. So I have question which will take definitely a long time. So I think we have started it at like in my time it was 22:50. At that time we have started and it's 23. Okay, now it's 50. So it's 1 hour.
yeah.
It's completed.
Okay.
Okay, so rest of the chapter will continue in the next lecture. Okay.
Okay. Thank you.
Thank you. Bye.